Hello, ladies and gentlemen. Before we move on to this sheet, let me open up a little bit. We got some things I need to talk to you about. So we've got some exponent laws on the side here, and it says that the law for multiplication, if the bases are the same and we multiply them, then the rule is it's going to be bx plus y. And we talked about that, and I explained that, and we had a really good discussion about why that was. But we're going to add those exponents if the bases are the same when we're multiplying. And we learned that when we divide, we're going to be subtracting those exponents. Now, I like to use Fruit Ninja, but ultimately we are doing some subtracting. And when you have a power to a power, so when you have a power to an exponent, those get multiplied. And I'm going to use the symbol of a dot there to multiply those two. And remember, that's different than adding. But there's two that I haven't talked to you about. And one of them is that no matter what the base is, base can be anything at all. When the exponent is 0, it always equals 1. It always does, no matter what the base is. And when I have a base with a negative exponent, well, if we think about this as being over top of 1, so I make a fraction. Now, that's not a big deal. Let's not freak out. That's not wizardry there. If I have a number like 9, we know that it's actually 9 over 1. And if I have a number like 12, it's actually 12 over 1. And when I do that, what I'm creating is a numerator and a denominator. And so it says 9 divided by 1. Well, 9 divided by 1 is 1, and 12 divided by 1 is 12. But I create what I'm going to call a top and a bottom. So when I have b to the negative x, anything at all, 3 to the negative 2, well, why don't I use something you've seen before? 10 to the negative 3. So when I have 10 to the negative 3, then if the exponent's negative in the top, it's going to be positive in the bottom. Now that's wizardry. That's really, really cool. So if I had 3 to the negative 2, what I would do is I would say, well, the exponent's negative in the top, so it's going to be positive if I bring it down to the bottom. And I'm going to freak you out here. What if I had a negative exponent in the bottom? Well, yeah, it's going to become positive in the top. Now, let's be very, very clear. What's happening is I'm getting rid of that negative exponent by moving it from the top or the bottom. It's the exponent that's changing. If I have negative 6 to the negative 2, then that becomes 1 over negative 6 to the 2. This 6 doesn't become positive because it went to the bottom. This is just an exponent thing, okay? Now, so those are two things that I haven't taught you yet. Well, we've kind of seen it, but we're going to look at it. So this would become 1 over b to the x. Let's talk about why this is what it is. So if I had, let's say, a to the 4 over a to the 3. Well, we know that the shortcut method is to go a to the 4 minus 3 is a to the 1. We know that. That's the truth. And we've also seen earlier today that we can think of this as 4 a's being multiplied on the top and 3 a's being multiplied on the bottom. Well, Fruit Ninja time. They reduce down to 1. Now, some of you stop me and say, why does it reduce down to 1 and not down to 0? Well, the answer is, if you had 5 divided by 5, the answer is 1. They reduce down to 1, not 0. 5 divided by 5 is 1, not 0. So a divided by a is 1, not 0. So you've got to keep the 1s. Fruit Ninja again. Fruit Ninja again. And look what it left me with. It left me with a to an invisible exponent of 1. Now, that shouldn't be too thrilling. Let's try it again. A to the 6 over a squared. So a times a times a. A times a times a, 6 of them, over top of a times a. Well, the shortcut way of doing it is a to the 6 minus 2, which is a to the 4. And if we look at what's happening, nope, sorry, that one doesn't get reduced. So 1, 2, 3, 4, I get left with a to the 4. Now, that shouldn't be exciting. That should be, Mr. White, you've gone off the deep end. We get this. You've shown it to us. Why are you talking about this still? Can't we move on? And I would say, yeah, I think we can move on. Let's move on to a to the 3 over a to the 3. And you're going to go, okay, then let's move on. A to the 3 minus 3 is a to the 0. Okay. And doing it the other way, now I'm using the dots to represent timesing. Reducing. 1 times 1 times 1 on top, divided by 1 times 1 times 1 on the bottom. A to the 0 equals 1. And it doesn't matter what the base was, because whatever the base is, it's going to cancel out and leave me with 1. I'll have the same number of the bases on the top as the bottom, and they will simply cancel out. So that's why anything to any base to the 0, any base to the 0 will be equal to 1. And that's all I have to say about that. And so I just taught you something cool. I just taught you this rule here. The base of anything to the exponent 0 is 1. Now, okay, let's move on, as we say, and let's now do something more interesting. Well, we know the rule. The rule is a to the 3 minus 5, which is a to the minus 2. So that's negative. All right. And so what it means is a times a times a times a times a times a times a. So there's 5 on the bottom and 3 on the top. Fruit Ninja, yay, yay, yay. Yeah, I'm left with 2 on the bottom. Which means that 1 over a squared, that 2 on the bottom and 1 on the top, equals a to the negative 2. And that's why it works. Okay, so, and it doesn't matter what I do that with. If I do it with 3 to the 7 over 3 to the 9, well, that was, so I got to write out all these. So I'm going to have 7 3s on the top, right? I'm going to have 7 3s. And I'm going to have 9 3s on the bottom. So where are there more 3s? There's 2 more 3s on the bottom. So I'm going to be left with 1 over 3 squared. Now that just makes sense, right? That's what I'm going to be left with. I didn't write them all out and cross them. I think we can figure this out. And if I was to do this using our shortcut, it's 3 to the 7 minus 9 equals 3 to the minus 2. And so what that means is that 3 to the minus 2 is equal to 1 over 3 squared. And we remember that by this trick, if you will, or this way of thinking about it, that if I have something with a negative exponent in the top, then it will be the same exponent but positive in the bottom. And if I had something with a negative exponent in the bottom, well, it'll become the same exponent positive in the top. And then if I end up with something like this, well, then switch them. Let's put the b to the m on top and the a to the n on the bottom. And we like our answers always to have positive exponents for the most part. We generally don't give any of our answers with negative exponents unless they're asked for directly. And I think I'll stop there, and then I'm going to come back. And what we're going to do, I want you to pull this page. Well, you know what? We're not going to stop. We'll just finish this. Let's pull this page out, and I'll do the top ones, and then you can practice the bottom ones with the answers at the bottom here. So we're going to evaluate each of the following. So 2 to the 9. Now, the word evaluate is really important. You need to know what that means. That means find, or not really find, but determine the numerical answer. So you want a number. When they say evaluate, they want a numerical answer. So you're going to grab your calculator and you're going to go 2, y to the x, 9 equals, and the numerical answer is 512. That's what the numerical answer is. I could have sat there and gotten 2 times 2 times 2, but you get the point. 10 to the 0, well, it's 1. Anything to the exponent 0 is 1. 7 to the negative 1/3, well, that's going to be 1 over 7 to the 3. That's what it's written as a fraction. And that's going to be 1 over 373, I think. 7 to the 3, watch it be 43. See, it's 43, not 73. All right. And that is going to be 1 divided by 343 is, well, look at that, scientific notation. So that decimal place gets moved over 3 points. So it's going to be moved over to 0.0029, etc., etc. So it's approximately equal to that. Isn't it a good thing that I taught you scientific notation? That's so great. All right, simplify using exponent laws. So write your final answer using positive exponents. So we have to use bedmass here maybe. So I got these guys. Now notice that it's multiplication. So the bases are the same, so I can add the exponents. And then I'm going to use the power to a power rule, and 19 times 3 is going to be 57. So it's 4 to the 57. Now notice it didn't say evaluate, because I don't want to evaluate something like that. Look how big this would be. That's crazy. I don't want that. This is a fine way to write that. So that's why it says simplify using exponent laws. And write your final answer using positive exponents only. Okay, so now I've got 3 to the 13 over 3 to the 17. Well, I like to think about it this way. I actually rewrite it so I can see it that way. And that's a 17. I know, I got weird writing. So 13, 17, where are there more 3's on the bottom? How many more? 4. And so I get that, and it's not a problem for me. If you do this a different way, if you do 3 to the 13 minus 17, you're going to get 3 to the negative 4, and then to satisfy the question, you need to write it as 1 over 3 to the 4 because I don't want any negative exponents. All right, over here. So we need to simplify the top, simplify the bottom, then put it together. So the top one's going to be 6 to the 20, the bottom one's going to be 6 to the 11. And where do I have more 6's? On the top, how many more? 9 more, so it's 6 to the 9. And yeah, so the rest is practice, and you can get going on that.